Section: Introduction. In this section, we introduce the concept of synthetic data, which is data generated by models or algorithms rather than directly by humans. Synthetic data is becoming more important for training large language models, LLMs. There is a growing interest in using LLMs to create synthetic data by providing a data synthesis prompt. However, creating diverse synthetic data at scale is challenging. While we can increase the quantity of synthetic data easily, ensuring its diversity scales up as well is difficult. When an LLM generates synthetic data without considering sampling, it can only produce one instance based on a data synthesis prompt. To create diverse synthetic data at scale, such as 1 billion diverse math problems, we need a large number of diverse prompts. Previous research has focused on diversifying data synthesis prompts using two main approaches: instance-driven and key-point-driven. However, these approaches have limitations in creating scalable synthetic data. To address these challenges, we propose a new method called persona-driven data synthesis. By adding a persona to a data synthesis prompt, we can guide the LLM to create unique synthetic data from different perspectives. We have created a persona hub, which contains 1 billion diverse personas representing a wide range of knowledge, experiences, interests, personalities, and professions. These personas can help generate diverse synthetic data at scale without being restricted by the size of a seed corpus. Unlike key points that are specific to certain data synthesis prompts, personas can be combined with almost any prompt, making them versatile for various data synthesis scenarios. We demonstrate the effectiveness of Persona Hub in creating math problems, instructions, knowledge-rich texts, game NPCs, and tools. This persona-driven approach is flexible, scalable, and easy to use, potentially revolutionizing synthetic data creation and its applications in LLM research and development. To support research in persona-driven data synthesis, we have released 200,000 personas from Persona Hub along with synthetic data samples. We are open to releasing more data as we address potential risks and concerns. Our methodology can be applied to most popular LLMs, and interested readers can verify it using the persona samples we have provided. It is important to note that our focus is on creating new synthetic data, unlike previous research that mainly generates synthetic outputs for specific inputs, such as math problems. Section Summary. In this section, we explore the challenges of creating diverse synthetic data at scale using large language models, LLMs. While previous methods like instance-driven and key-point-driven approaches struggle to achieve scalable synthetic data creation, we introduce a novel persona-driven methodology. By leveraging a persona collection called Persona Hub, which contains 1 billion diverse personas, we demonstrate how personas can guide LLMs to generate versatile and scalable synthetic data across various domains, potentially revolutionizing synthetic data creation and LLM applications. Section: Persona to Persona. In this section, we discuss how we can enhance the diversity of personas by introducing persona to persona. While text to persona is powerful, it may miss personas like children, beggars, or behind-the-scenes movie crew members. Persona to persona helps us derive personas with interpersonal relationships from those obtained through text to persona. For example, a persona about a child can be derived from a nurse at a children's hospital. We expand persona relationships through 6 iterations for each persona obtained via text to persona, following the 6 degrees of separation theory. To manage the large number of personas obtained, we perform deduplication using min-hash and embedding-based methods. Min-hash helps us remove similar personas based on n-gram features, while embedding-based deduplication filters out personas with high semantic similarity. After deduplication and filtering out low-quality descriptions, we have a total of over 1 billion personas in our Persona Hub. Our persona-driven data synthesis approach involves integrating personas into data synthesis prompts to influence the creation of synthetic data. With 1 billion personas in the Persona Hub, we can easily generate diverse synthetic data. We can prompt a language model using zero-shot, few-shot, or persona-enhanced few-shot methods to create synthetic data tailored to specific requirements. We demonstrate the versatility of Persona Hub in various data synthesis scenarios such as math problem creation, generating instructions, knowledge-rich texts, game NPCs, and tool development. The persona-driven approach is adaptable by adjusting the data synthesis prompt, allowing us to create different types of synthetic data effectively. Section Summary. In this section, we introduce persona to persona as a method to supplement text to persona by deriving personas with interpersonal relationships. By expanding persona relationships through 6 degrees of separation theory, we enrich our persona collection further. We then employ min-hash and embedding-based deduplication techniques to filter out identical or similar personas, resulting in a total of over 1 billion personas in our Persona Hub. This approach drives synthetic data creation by integrating personas into data synthesis prompts, influencing language models to adopt different perspectives and create diverse synthetic data at a large scale. Section: Data. In this section, we selected 1.09 million personas from Persona Hub and used the zero-shot prompting method with GPT-4 to generate math problems based on these personas. We did not use any examples from benchmarks like math while creating these math problems. This method allowed us to create 1.09 million math problems. Instead of focusing on solving these problems, we used GPT-4 to generate solutions for them. Out of the 1.09 million math problems, we set aside 20,000 as a synthetic test set for evaluation purposes, while the remaining 1.07 million problems were used for training. For evaluation, we used 2 test sets: the synthetic test set, in distribution, and the math test set, out of distribution. The synthetic test set was created in the same way as the training instances and contained 11.6K test problems. We ensured answer accuracy by generating solutions using different methods and only retained test instances with consistent solutions. The math test set is a well-known benchmark containing 5,000 challenging math problems. Since we did not use any data from the math dataset for training, we considered it an out-of-distribution test set. To check answer equality, we followed a similar protocol as OpenAI for the math benchmark. We fine-tuned a large language model with our synthesized math problems and evaluated its performance on both test sets. Our model achieved nearly 80% accuracy on the synthetic test set, outperforming other models. On the math test set, our model achieved 64.9% accuracy using greedy decoding, ranking well among other models. We also assessed the quality of our synthesized math problems and found a high validity rate. Additionally, we examined how differences in personas affected the similarity of the generated math problems. We observed that the semantic similarity between math problems tends to be lower than the similarity between personas. However, when we added specific constraints to the prompts, the similarity between math problems increased. Overall, using personas from Persona Hub ensured diversity in the synthesized data even at a large scale. Section Summary. In this section, we select 1.09 million personas from Persona Hub and utilize the zero-shot prompting method with GPT-4 to generate math problems without relying on existing benchmarks like math. This approach enables the creation of 1.09 M math problems, with 20K held out for a synthetic test set and the rest used for training. We evaluate our model's performance on in-distribution and out-of-distribution test sets, achieving nearly 80% accuracy on the synthetic test set and 64.9% accuracy on the math benchmark, showcasing promising results for a 7B model trained with synthetic data. Section: Logical reasoning problems. In this section, we discuss logical reasoning problems and how our persona-driven methodology can be used to create a variety of content. We provide examples of logical reasoning problems synthesized using our approach, including Rujiba-style problems. These examples illustrate that by clearly defining the requirements for a problem, we can use different personas to guide the language model, LLM, in generating diverse and relevant problems. For more examples, readers can refer to the 50,000 synthetic reasoning problems we have made available. When it comes to generating instructions for LLMs, we can simulate various users using Persona Hub to understand their needs. This results in different types of instructions, such as zero-shot prompts and persona-enhanced few-shot prompts. The zero-shot method allows the LLM to create instructions without relying on existing datasets, while the persona-enhanced few-shot method uses existing datasets to generate instructions that closely resemble those from real users. By creating diverse instructions with Persona Hub, we can improve the LLM's ability to follow instructions and engage in conversations. Additionally, our persona-driven methodology can be adapted to create knowledge-rich text for pre-training and post-training of LLMs. By prompting an LLM to write content like a Quora article based on a persona, we can generate informative text covering a wide range of topics. This process can be scaled using Persona Hub to produce a vast amount of knowledge-rich content. Another practical application of Persona Hub is in creating non-player characters, NPCs, for games. By providing background information to the LLM and projecting personas from Persona Hub onto game characters, we can streamline the NPC creation process during game development. Furthermore, Persona Hub can be used to anticipate user requests for tools or functions that an LLM can provide. By pre-building these tools based on predicted user needs, the LLM can efficiently respond to user requests without having to develop tools from scratch each time. This approach expands the range of services offered by the LLM and enhances user experience. Our persona-driven methodology represents a paradigm shift in data creation by enabling LLMs to not only process data but also create new data from different perspectives. While LLMs may not yet fully replace humans in data creation, advancements in LLM capabilities suggest a future where LLMs excel in generating diverse data types. Persona Hub ensures the diversity and coverage of synthetic data, addressing concerns about data quality and scalability. This shift may ultimately eliminate data bottlenecks and enhance the capabilities of LLMs in data creation. Section Summary. In this section, we explore how logical reasoning problems can be synthesized similar to math problems using a persona-driven methodology, showcasing examples of such problems. By leveraging Persona Hub, we can simulate diverse users to generate a wide range of instructions for LLMs, enhancing their conversational abilities and instruction-following skills. Additionally, the persona-driven approach can be extended to create knowledge-rich texts for pre-training and post-training LLMs, as well as to develop NPCs for games, predict tools users might need, and potentially revolutionize the paradigm of data creation by enabling LLMs to generate new data from various perspectives. Section: Reality Simulation. In this section, we have shown that Persona Hub can represent a wide range of real-world individuals with its 1 billion personas. By using these personas to simulate and predict the needs and behaviors of real users, we can help LLMs get ready for future queries and better imitate the real world. This opens up many new possibilities. For example, companies can forecast how different users might respond to a new product launch. Governments can anticipate public reactions to new laws across various population groups, and online services that rely on user profiling can benefit from Persona Hub to simulate diverse user behaviors, easing the cold start problem. The diverse personas in Persona Hub can support research on LLM roleplay, agent collaboration, strategic reasoning, and related areas. Moreover, these 1 billion personas could even sustain a structured society within a virtual world like sandbox environments, online games, or the metaverse. This virtual society can act as a testbed for new policies, radical ideas, and social dynamics, offering valuable insights before real-world implementation. By observing how different personas interact in a controlled environment, we can study emergent behaviors, test theories, and improve strategies without risks. This not only enhances our understanding of complex systems but also accelerates innovation by enabling quick iterations and experiments. When we engage with an LLM, we only access a fraction of its memory and capabilities. However, Persona Hub potentially allows us to tap into the full memory of an LLM by leveraging its 1 billion personas. By creating diverse queries using these personas, we can transform the LLM's comprehensive memory into textual data. This distributed compression of world knowledge offers a way to decompress the LLM's parameters back into the information it has learned. Although current limitations exist, as Persona Hub evolves and LLMs improve, we may eventually extract an LLM's full memory into plain text almost perfectly. While Persona Hub provides access to an LLM's full memory, it raises concerns about training data security. Extracting a target LLM's memory essentially reveals its training data, even though this process is usually not perfect. If we synthesize instructions covering various use cases to query a target LLM at scale, there is a risk of extracting and replicating the LLM's knowledge and capabilities. This could challenge the dominance of the most powerful LLMs, as discussed in a previous section. This shift may impact current practices and lead to a change in the competitive landscape of LLMs, focusing more on advanced technologies than data advantage. Synthetic data generated by Persona Hub raises worries about misinformation and fake news, as diverse personas may make machine-generated content harder to distinguish from human-created content. This difficulty in detection could exacerbate issues like data contamination, where synthetic data mixes with real data, potentially skewing research outcomes and public information.